This video is all about the average value of a function. But before we get into the how and why of this topic, the first question that we're going to address is what does it mean to average a set of values? And this is something that hopefully we're pretty familiar with. The idea of averaging is a way to balance or redistribute all the values in a set of numbers. So we'll start with an example that people are most likely to remember. Suppose that you wanted to average the temperature outside at noon for the 7 days in a single week. How would you go about calculating this? Well, this is the average that most of us are taught first, where we would add all 7 temperature values and then divide by 7. Take the 7 various values, add them all up and divide, and then they become one balanced value for the entire week. So following that up with a second example, which still should be easy enough to think through. Suppose you wanted the average daily high temperature for some particular city over the course of an entire year. And for our purposes, we're going to say this is a non-leap year. Well, it'd be very much like the first example. We would add all the values, all 365 of them, and then divide by 365. And that's a lot of numbers we would have to add up. But it's not impossible. With the use of spreadsheets and technology, this would be relatively easy to calculate. But now let's look at a third example, the one that will lead us into the rest of this lesson. Suppose that you want the average temperature outside over the course of just one day. And here's the first time we're going to run into a major issue. Temperature is a continuous set of values. It's not just 20 degrees, 21 degrees, it's every infinite decimal in between. So this is a continuous set of values over time and not discrete or unique values like we saw in the previous two examples. There are infinitely many temperature values over the course of one day, even 1 hour. So it is not possible for us to add and divide to get this average temperature, unless we rethink how we do addition. So let f of t be a continuous function that models the outdoor temperature measured in degrees Fahrenheit for any time t, which we measured in hours. And this model will apply over the course of one entire day, or 24 hours. And we'll say that day goes from midnight to midnight. T equals 0 to t equals 24 hours. And just to give a quick visual of what this could look like, let's say the temperature at midnight starts a little bit lower, goes up through the middle of the day, and then goes back down as we get to the second midnight. Here's a graph giving us the temperature over the course of these 24 hours. And just recall what we started with. Average simply means to balance out. So if we think about putting all of those individual temperatures together, what we'd be looking at is the area under this curve. The area under f is the sum of all our temperatures, and we would denote that as the integral from 0 to 24 of f of t with respect to t. In order to average, just think, what if we could balance out that area into the area of a different shape that has a constant value along the top? say a rectangle. If we could make a rectangle that has the same area, but an equal function value throughout, the constant height of this rectangle would represent our average value. Now thinking geometrically, the area of the rectangle shown in the picture would be 24 for that time interval from 0 to 24 times whatever its height is. And that height will represent the average value. Some value that helps us keep the same area, or sum, but balances all the function values to one constant number. So now we can say that we're actually setting the area of our rectangle, 24 times the average value, equal to the area under our f function, which was the integral from 0 to 24. And solving for the average value would yield 1 over 24 times the integral from 0 to 24 of f of t dt. The integral has taken the place of the addition we normally do on an average calculation, and dividing by the interval has taken the place of dividing by the number of values in the data set. And if you're not sure if this works out in context of the problem, think about the units. 1 over 24 would be 1 over 24 hours, and the integral itself would have units degrees Fahrenheit times hours. The hours would cancel, and our result would be a value for degrees Fahrenheit, which are the units we want if we're talking about the average temperature. So in general, given a continuous function, call it f of x, on a closed interval a to b, the average value for f of x on the interval is given by the formula 1 over b minus a, 1 over the width of the interval, times the integral from a to b of f of x dx. And that is the calculation that allows us to calculate the average value for any continuous function over any interval. And just keep in mind, this is the same average calculation you've always done. The integral is our sum, and the width takes the place of the number of values that exist in our data set. That's all for this lesson on average value. Thank you for watching.